So we are on concentration of solutions. Now a solution is a homogeneous mixture of what? A solute and a solvent. So when I put sugar in water, sugar is solute and water is solvent. Right? I form what we call a sugar solution. Now let's look at concentration of solutions. Amount concentration. It is also known as molarity. Please, not molarity. Molarity. We have molarity there, right? In kilograms. Molarity. It is the amount of substance dissolved in 1 dm cube of a solution. Now that is the formula. C equals number of moles over the volume of what? Solution. Now C equals N over V. So when we use this formula, we can calculate the concentration of the solution in moles per dm cube. This is the only formula which can give you moles per dm cube. Amount concentration. Mass concentration is the mass of a substance dissolved in 1 decimeter cube of the solution. So it is a mass of the volume. So we have two formulas here, right? Mass over volume, and here we have concentration by molar mass. You normally see these formulas in most practical questions, right? When you are doing titration questions, right? Good. Now they will give you something, maybe a substance in the impure form. And you have to calculate the mass concentration for that substance before you can get the actual concentration by using this formula, right? So we have instances where we learn these formulas. But they are all formulas for mass concentration, right? It's just the mass of a substance dissolved in 1 dm cube of what? A solution. Now, let's see something here. 1000 cm cube equals 1 decimeter cube. It's the same as what we call 1 liter. When you take your sachet water, it's written 500 ml. And ml, this is milliliter. Milliliter. Milli in mathematics means divided over 1000. Are you okay? So it means the pure water or the sachet water that you drink is 0.5 liter, it's half a liter. But it is tagged 500 milliliter, ml. Are you okay? So anytime you see ml, this m here is tantamount to 1000. Okay? Divide by 1000. So it can be 500 times 10 raised to the power minus 3. Or physically writing, 0.5 liter, okay? So 0.5 liter is also the same as what a dm cube. So a dm cube is equivalent to what? A liter. Application. 0.5 grams of sodium carbonate is dissolved in 300 cm cube of water to form a solution, right? So it dissolves in 300 cm cube of water to form a solution. Now determine the concentration of the resulting solution in I mole per dm cube, and I grams per dm cube, and I moles per liter. Okay, moles per liter. So the solution to our problem here. I have the mass, so you look on when I finish, you take a portion, right? I have the mass 0.5 grams, and I have the volume to be 300 centimeter cube. Now determine the concentration of the resulting solution. Now I have to look for the concentration in moles per dm cube. The only formula which can help me to get moles per dm cube is the amount concentration technique, right? So I know that I have C plus N over V. This is my formula. I don't know my number of moles, so I have to go look for the number of moles from that which I taught you number of moles, right? So you have number of moles equals mass over what? Molar mass. Now I have to look for the molar mass, right? Molar mass of what? Sodium carbonate. Now molar mass is given by the mass of 1 mole of a substance. Now this is sodium, it's 23. It appears twice. Are you okay? Carbon is what? 12. Oxygen is 16. It appears 3 times. That is why you have this, okay? So what will be the molar mass here? Compute everything here. So 106 gram per mole. Now this is the unit for molar mass. 106 gram per mole. This is the unit for molar mass, right? Okay. Now you have this. Concentration is what? N over V. Okay. Now I have my number of moles. Now what is my mass? 0.5. What is my molar mass? 106. Yes. So this is the answer we are getting, right? So you are getting this mole. It is in the standard form, it doesn't matter, you don't need to convert it, okay? Just leave it. So concentration now is N over V. Now what did you get from your N? You see that? 4.71 times 10 to the power minus 3. That is mole. What is your V? Now anytime you are given a V, make sure you change your V towards dm cube. So this one will be changed to dm cube, right? It is just by divided by what? 1000, okay? So 300 over 1000 will give you a 0.3 decimeter cube. Why? You have been asked to calculate in moles per decimeter cube. If you don't change your volume term, you end up in cm cube. You understand? That is why you have to change your volume term to decimeter what? Cube. So there is 0.3 what? dm what? Cube. Yes. Mole slash decimeter cube, yeah. So there is a bar. If you remove this partition sign, that is where you bring the minus sign there, right? Now the next one, I've been asked to find what? Grams per dm cube, right? Grams per dm cube, right? So mass concentration can be concentration by what? Molar mass. What's the concentration here? Now what is the molar mass? 106, yes. 1 point what? Now this is grams per concentration, right? Concentration is in what's the unit? Gram per dm cube now, right? Okay, gram per dm cube. Good. Now the third one. I've been asked to calculate the concentration of the solution in moles per liter. I have to know something. If my volume is 0.3 dm cube, you know it is equivalent to 0.3 liter. Do you believe that? Okay, so concentration N over V is the same N that we use, right? The same N, 1.71 times 10 to the power minus 3. It is mole, right? Now what is the volume? 0.3 liter. I'll get the same answer again, but it will be in mole per what? Liter. Is that okay? Welcome to concentration. And be very careful. I wrote two examples, two formulas for mass concentration. I told you the mass over the volume is when we are trying to get the mass of the substance from the impure form, okay, doing titration. But when you are looking for the mass concentration without any impure form of any question, you just use this. Are you okay? So that is when we use it. The other one you only see it in the practical questions when you are doing it, right? Good. What mass of this? It means I'm looking for my mass. Will be required to prepare 250 cm cube. That is my volume, right? The volume term must be in what? dm cube divided by 1000. Yes. Is this 0.25? Good. Check. Now the concentration of the resulting solution is this. Now take note. This thing you see here the same as what you say molar. Okay? You can write this like this, the same as writing this. Right? So this is molar concentration, right? That's the time, it's not molar mass, please. That's, if it's molar mass, it will be a symbol, so it can't be found in the things, right? So, a mole per dm cube is molarity, it's the same as just molar, okay? So whenever you see this, it is also what? A concentration. Now, I've been asked to find the mass. Amount of substance equals mass over what? Molar mass. The molar mass of our sodium carbonate, I think we just found that, right? That is 23 by 2 plus 12 by 16 by 3, right? You're going to get 106 grams slash what? Mole. Now I've been asked to find my mass. So N equals M over what? The molar mass. So I can make my mass the formula here. Mass equals number of moles by what? Molar mass. Right? Good. Now what is the number of moles here? We don't know it. Okay. Then I think I still have to look for my what? Number of moles. You see that? So N equals mass over what? The molar mass. Good. Now number of moles, no, I can't use this. I'd rather use concentration equals N over V, right? so that I can generate my what? N. So this is 0.15 and the volume is what? 0.25. So I cross multiply. Do you see that? N is 0.15 by what? 0.25. Yes. 0.0. Okay. So this is my number of moles. Are you okay? I've used a symbol for the unit MOL. If you want to spell the units out, it's MOLE. Okay? MOLE moles has a symbol called MOL. It's just by coincidence. Now, number of moles equals mass over what? A molar mass. Now, what is the mass? It is N by what? The molar mass. Now, what is the number of moles? The molar mass 1016. Compute 3.975 watts gram. Are you okay? Good. So when they ask you to find the mass, it is what to do. Right? We have the concentration, we have the volume, so I was able to easily get what? The N. Good. Please know how to mix your parameters.